Okay, today we're going to review graphing linear equations, and then we're going to move from just graphing linear equations to graphing systems of equations. Okay, so here are the steps that we've talked about in class for the last couple of days on graphing linear equations. Your first step is to write the equation in slope-intercept form, which is y equals mx plus b. So you're basically just going to solve for y. The slope is the coefficient of your x. The number without a variable is the y-intercept. So to graph, the first thing we do is plot the y-intercept. Then we use the slope to get other points on the line. Okay, keep in mind that your slope is equal to rise over run. So let's take these steps and practice, and you can pause to take any notes that you need to take. Okay, so here's our first example. All right, we got 2x plus 7y is equal to 14. All right, 2x plus 7y equals 14. We're going to put it in slope-intercept form. We're going to start by subtracting 2x from both sides. We're subtracting 2x because in the original problem, the 2x is positive, so you want to do the opposite. That leaves me with 7y equals negative 2x plus 14. Divide each term by 7 so that the y is completely isolated. And you're going to get y equals negative 2 over 7x plus 2. Okay, your y-intercept is 2. Your slope is negative 2 over 7. As an ordered pair, the y-intercept is 0, 2. Slope being negative 2 over 7, it says to go down 2 and right 7. And we can also do the opposite, which means to go up 2 and right 7. So I'm just going to draw a little graph here. Yours will be much better because you have printed graphs that I have provided for you. Okay, so I'm going to start by going up to 2 to plot my y-intercept. Okay, that's where that point comes from. And then I'm going to use my slope to get a couple other points on the line. Right, your slope here is negative 2 over 7. So I'm going to come down to 1, 2, right 7. 1, 2, 3, 4, 5, 6, 7. All right, so I've run out of space. Now I'm going to do the opposite. I'm going to go up 2, 1, 2, right 7, left 7. 1, 2, 3, 4, 5, 6, 7. Okay, those are my points. Connect the point, and I have a line. Okay, and then for the second equation, let's make this a negative 3y. So we got negative 3x minus 5y equals 15. Since this 3x is negative, we're going to start by adding 3x to both sides because we want to do the opposite. These cancel. That leaves me with a negative 5y equals 3x plus 15. All right? And now I'm going to divide each term by negative 5 in order to isolate the y. And I'm going to get y equals 3 over negative 5x. A positive 15 divided by a negative 5 gives me a negative 3. Now, here with your slope, you can put the negative with the numerator or denominator. It doesn't matter. You just can't put it with both. So here, my slope is going to be negative 3 over 5. So that's down 3 and right 5. And your y-intercept is negative 3. So once again, draw me a quick little graph. Okay, I'm going to plot my y-intercept, which is negative 3. Now I'm going to come down 3. 1, 2, 3. Right 5. 1, 2, 3, 4, 5. Put a point. Up 3. 1, 2, 3. and left 5. 1, 2, 3, 4, 5. Put a point. Okay? So that's your review of graphing lines. And now we're going to move on to systems of equations. All right? So here are your notes for system of equations. And you can pause and as much as necessary to get the information. So when we're talking about systems of equations, system of equations, that's two or more equations graphed in the same coordinate plane. When we find our solution satisfies all equations in the system. So what that means is we can take one ordered pair, substitute it into all of the equations that's in the system, and it will satisfy all of your equations. Now, when we're graphing our systems, there are going to be three possible outcomes. Okay? And those three possible outcomes are listed in this chart below. Okay? Now, the first possibility is that we can have intersecting lines. When we have intersecting lines, the name of the system is consistent and independent. Consistent means that there is a solution. Independent means that there's one solution. So with intersecting lines, the number of solutions is going to be 1. And that solution is the point of intersection. The second possible graph are parallel lines. Parallel lines have no solution because they don't intersect. The name of the system is inconsistent. The third possibility is what we would call the same line, meaning two lines are going to lie on top of each other, and another name for same line would be coinciding lines. With coinciding lines, because they lie on top of each other, there are many solutions, and the name of that system is consistent and dependent. Now, it's very important that you learn this chart because on a quiz, you're going to have to be able to graph the systems and name the system as well. Okay, so now we're going to use those same steps we used for graphing linear equations, and we're going to graph our systems of equations. Okay, so my first system is 2x plus y equals 4 and x minus y equals 2. So I'm going to start by subtracting 2x from both sides because we're isolating the y, and you're going to get y equals negative 2x plus 4. Okay, here my y-intercept is 4. My slope is negative 2 or negative 2 over 1. So that means that we're going to go down 2 and right 1. Okay, for the second equation in the system, we're going to subtract x from both sides, and we get negative y equals negative x plus 2. Because this y is negative, now I need to divide each term by negative 1, and you're going to get positive y equals a negative divided by negative gives me a positive x. Positive divided by negative gives me a negative 2. So here, your y-intercept is negative 2. Your slope is 1 or 1 over 1. So that's going to be up 1 and right 1. So now, since I provided you with graphs, you can go ahead and work this problem right next to your graph. And so now I'm going to move it so that we can graph. All right? So a system, you're going to graph both in the same coordinate plane. So I'm going to start with this first one. The y-intercept was 4. So I'm going to go up 4, 1, 2, 3, 4, and put my point. The slope is negative 2 over 1. So it's down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Then I'm going to go up 2, left 1, up 2, left 1. I'm going to connect these points. Doesn't matter if the line is straight or not, as long as we have our points in the right location. And then the second equation had a y-intercept of negative 2. So I'm going to come down to -2 and put a point. My slope is 1 over 1. So it's up 1, right 1, put a point. Up 1, right 1, put a point. Up 1, right 1, put a point. And I think I have enough. So I'm going to connect. And as you can see, these are intersecting lines. If you go back to your chart, because the lines are intersecting, then that means that this is consistent and independent. Okay? Consistent and independent has one solution. That solution is right here, which is the point of intersection. And that ordered pair is 2 and 0. Okay, we can check. We got 2x plus y equals 4. 2 times 2 plus 0 equals 4. 4 plus 0 equals 4. So 4 equals 4. It checks in the first equation. Your second equation was x minus y equals 2. 2 minus 0 equals 2. And 2 equals 2. It checks in the second equation. So that tells me that we've graphed this correctly. Okay, so the only thing that we're doing differently is instead of having a different graph for each equation, we're now putting two equations on the same graph. All right, so now I want you to take a minute and try the practice problems that I've assigned to you for homework, and let's be prepared to go over those in class tomorrow.